Hi, good afternoon, everybody. Welcome, thank you for joining us. We have a great turnout here today. My name's Mike Kuntz. I'm a Senior Solutions Architect with Amazon Web Services. With me on stage today, I have Stephen Carter.
Yes, I'm Chief Cloud Architect at Red Hat Public Sector.
Yeah. So just to start off, I want to baseline the room and see where everybody's at. Can I get a show of hands? How many people are new to AWS? You maybe only are doing proof of concepts. Don't be shy, raise your hands. Okay, thank you. We kind of want to know as we do the conversation today, where to set the expectation. How about people doing production? Oh, one or two. All right. How about production applications? You have a lot of stuff. You're doing like a year or two more. Great. How about all in? Everything's in AWS. Great. Check those people out. Follow them around later. They will answer a lot of questions for you and show you how everything's done. We're going to talk today about continuous integration, DevOps, but we're going to start here with applications and infrastructure. So traditionally, when you look at the way IT has been done, right, you have your developers over here and your sysops or your operations or system administrators over here. Really, what we're going to talk about is getting them to work together in this DevOps model and some of the tools that you can use to do that. We're going to talk about infrastructure as code. So this DevOps talk today is going to be more focused on the application infrastructure components and infrastructure as code. We're going to talk about continuous integration and continuous deployment pipelines. Lots of automation. I will say automate at least 10 more times today. Steven's going to say it a few times, like just going to drive home automation. And then we're going to talk about Ansible as well. Some of the principles for DevOps, really, when we talked about the development team on one side and the operations team on the other, is getting them to work together, to be one team, breaking down the barriers and more quickly scaling the environment, doing deployments, and working together. Company that I worked at prior to joining AWS, we had these two silos, and to get anything done was horrible. The DevOps or the development team would have to talk to the system administration team, and then there's usually some kind of battle, and it was just to deploy code, and it was painful. What we're looking at for DevOps is bringing those two teams together to more quickly and do an agile way to deploy code and infrastructure. Automation, I said, I'm going to say that over and over again. Testing. It's a really big part of what we're going to do with this. How do you know if it's working if you're not testing it, if you're not automating that testing, and then the measuring and monitoring of the applications and infrastructure once they're deployed? Uh-oh. Do you guys, I broke it. Sorry, everyone. That's what that button does. Okay. Okay, that's fine. All right, and then DevOps best practices. So again, infrastructure as code. Show of hands, how many people are familiar with this term? They've heard of this before, infrastructure as code? Good, this is great. A lot more people have heard about this. It's the idea of taking your source code, like your developers are doing, you check it in, and you promote it through changes. When you look at the infrastructure as code, tools like CloudFormation and AWS, you can take your entire environment and templatize it in a JSON or YAML formatted text file, and you check it into a source code repository just like your developers are doing with the code. Using CloudFormation, you can define what a VPC looks like, what your subnets, your firewall security groups, the servers that you're launching. You can go through all the AWS services and launch those as well. And again, you're going to automate all of this, and we're going to talk a little bit more. The continuous integration piece of it, focusing on infrastructure today. Continuous deployment. It's another thing where we go through and we see small iterative changes that you can go and roll out your infrastructure. No more taking Saturday night at 11 o'clock from 6 a.m. Sunday morning and rolling out a whole new infrastructure change. What we're talking about are small little changes to your infrastructure, maybe a config change, and the ability to roll those out over time and detect changes, faults, problems, or success. And then again, monitoring and logging. Oh, you're kidding me. So some of the benefits of DevOps and the continuous integration and continuous deployment pipelines that we're going to talk about today. So increasing that velocity and feedback of the cycle through iterative changes. So where I mentioned before, a small configuration change maybe to your web server configuration files, instead of full-blown changes in a change window over multiple hours, and then also containing that change. So if you see a fault, because you have the automation in place, you have the monitoring and the testing in place, you identify it quickly, and you can roll back quickly, right? So if you think about the idea of just doing a small configuration change for your IIS or Apache web server configs, if it's just a small change, you can quickly roll that back out, pull a web server out of a load balancer, whereas if you now go instead, the old way, you deploy this to all your web servers, hope and pray, this is a much better way to go through and do this. On the continuous deployment part, how many people are familiar with A/B testing and what that is? Again, show of hands. Okay, so A/B testing, if you look at it in terms of like development, take a simple website, right? Amazon.com, everybody's familiar with. Up in the top right, you have the Buy Now button or Add to Shopping Cart. Take a look at this and you see the original version that's up there. Somebody looks at a product, they click Buy Now, and you see 50% of the people end up going through and buying it. Version B, you roll out, you move the button maybe down to the bottom of the page. You see now that only 30% of the people go through that whole buy-through process. That's a problem. Move it up to the top left on the other side. You now see 70% of the people. Oh, this is great. These small little iterative changes. You can do this with your infrastructure as well. So I talked about a configuration file that you use for Apache or IIS on Windows. You make that small change to the configuration file, you push that out to your infrastructure, and then you take a look at the measuring, the monitoring that you have in place. So you look at maybe what the average response time is to your website. So you see that, okay, it was sitting there and my response time was under a second. Now that I've deployed it, my monitoring's kicking off that it's over a second. I know there's a problem, I'm gonna roll it back quickly, pull those web servers out of the fleet, push new ones back in. Some of the benefits you get with this really are unlocking the benefits of the cloud. So that agility, the ability to scale up quickly, pull services in and out as needed. Security, because you're using infrastructure as code, you've templatized and baseline your entire infrastructure stack. You know what that looks like. There's no changes to one web server, but aren't changes to the rest of the fleet. You can go through and do code review with your security departments. They can take a look at your infrastructure. You can do approval processes through this integration and deployment process where there's a manual authorization check that maybe someone in security needs to take a look because a firewall rule or security group change was made. Some of the other benefits we see with infrastructure as code is really realizing these DevOps efficiencies of your infrastructure management. And releasing friction, right? The ability to go through and do these small changes without having to get everybody's approval, everybody's involvement, and if there's a problem, you can roll back quickly. Up here, we have a continuous integration workflow for a typical developer or application. You see code is checked in, goes up to Jenkins, a continuous integration server. It's built, tested for the individual units, packaged, maybe deploy into the application, the infrastructure. Literally for infrastructure as code, we're looking at that same workflow, that same pipeline where we're going to go through, but that code is going to be Ansible playbooks, which Steven's going to talk a little bit more, Chef, your CloudFormation stacks that you're using for all of your infrastructure, or Terraform. Continuous delivery pipeline, again, it doesn't look much different as infrastructure as code as it does for your application and development teams. Those of you in the room that are system administrators, sysops, you should spend some time with your developers and ask them about this. Ask them how this works, how they do this, and start leveraging some of that knowledge base that they have. With that, I'm going to hand it over to Steven. Do not hit the bottom button.
I'd like to for making the mistakes before I make them. It's, again, Stephen Carter, Red Hat, good to be here. So we've heard several times today and even in the last 10 minutes how DevOps is awesome. We all need DevOps. The problem is if you implement DevOps without addressing some of the hindrances, some of the bottlenecks in your infrastructure, you can greatly diminish or even obviate the benefits of implementing DevOps in the first place, right? So the problems that were there before will very likely be there after. So what I want to do is talk to you today about automating some of those bottlenecks, starting with systems thinking, and based on work that probably most people have read, Phoenix Project and the goal. Basically, it introduces lean into the IT process. But it's basically the idea that manufacturing and IT only move as fast as the slowest component, and optimization anywhere but the bottleneck is an illusion. So where's your bottleneck? Everybody in their IT organization, most likely, unless you're one of the lucky few, have someone or something that hinders the people behind from being able to start work and hinders the people in front of them from being able to finish work, right? So what you end up having is a very large backlog and a very large work in progress, both of which are inefficient in IT. So there it is, there's our bottleneck, right? Kind of obvious. But if we think about in our organization what's truly the bottleneck in many instances, it's generally this person. Right, I mean, everybody has infrastructure of some sort, right, and much of it is still physical. And physical infrastructure is a different animal, especially networking, right? It's full of spells and incantations that very few people understand. And so there's generally one person, maybe in each sort of vertical domain, in which that person is almost solely responsible for designing the infrastructure, is usually there to maintain it and fix problems. And when something really goes wrong, you want that hero to be there to fix it. The problem is that heroes are in very high demand. Everybody wants a piece of the hero because the hero is fixing things for everybody. And everybody is the most important person in the world. And everybody's VP is always telling them that they need this tomorrow, so the hero must comply immediately. And so very often that takes the hero off of the company priorities, which is a bad thing. The other problem is that both bosses and recruiters like heroes. And so since this hero has all these spells and incantations in their head, if that hero leaves, either willingly or not, very often your whole your institutional knowledge leaves with that person. So how do we fix this? How about we learn the clicker? Okay, well, we'll do it this way. So how do we fix this, right? Option one is to run at the speed of the bottleneck. And this is kind of what you see in standard lean IT, lean manufacturing, right? What this does is it reduces your backlog, it reduces your work in progress, but it doesn't really give you transformational change. How about we fix the bottleneck? Well, how do we do this? That's the slide I wanted earlier, by the way. How about hero as code, right? Sort of like infrastructure as code, but what we're really wanting to do is we are wanting to help this person take all of their experience, all of the knowledge that they have, and take it and translate it into code so that it becomes something that transcends that hero. It's an organizational resource that people can share and add to. Basically, what you want to do is you want to define your intent and your policy, your architecture for your networking, your storage, and your servers, and your cloud, and all of the things, and apply it across all devices, all vendors in an infrastructure agnostic way, into code that can perfectly describe that infrastructure, perfectly describe the end state that you want at which you want that infrastructure. And then once you've got this code, you can inject this code into the DevOps process. Gives you two things, really, right? The topic of this talk is really automating your infrastructure so that you can include it into your DevOps process, and that's assuming that you already have a DevOps process for developing applications, because, again, organizations are about applications and data. It's not about infrastructure. And so you've got this process for being more agile, capital A, or little a if you want to use DevOps, big D, right? So one of the buzzwords, you want to be more agile in delivering artifacts out to your customers. So you've already got this, and you want to include infrastructure in that process. However, even if you don't have that process, translating infrastructure into code and treating it at least in a DevOps-like way gives you things that most people don't have. It gives you revision control. It gives you configuration management. baseline that, again, a lot of people aren't doing nowadays. It allows you to ensure an ongoing steady state because you've got the end state that you're trying to achieve, and you can always make sure that your infrastructure is a reflection of that end state to find deviations from that baseline. It gives you automated testing to reduce human error. Imagine deploying infrastructure like networking, testing it before it ever hits a production switch, right, which greatly increases the likelihood of success. But then if you don't have success, you can actually step back very quickly to the last known good state. That's something you just don't get when your heroes are handcrafting configurations based on the needs of that particular day or that particular to address the needs of the noisiest user that day. And don't get me wrong, I have nothing against heroes. I actually used to be one of these heroes. Well, okay, wasn't a hero, but I actually sat really close to a hero and said hi really often. But still, I'm not out to get any of these heroes. So finally, what you want to do is you want to be in a place where you're starting to communicate with code. You don't want to communicate with indefinite pronouns and out-of-date diagrams and partial sentences. You want your developers to be able to specify in code what they need from the infrastructure, very specifically. And then you want your operations staff to be able to take that code and reconcile it with the infrastructure and how that infrastructure has to be delivered. And then you want your security team to be able to look at all of that, right? Because they don't have to guess how something is instantiated or set up from out-of-date document or from a person using imperfect words. They can actually look at the code and all work together to be able to deliver a secure, accurate infrastructure. Today I'm going to talk about doing that with Ansible. What is Ansible? So it is a simple automation language that can perfectly describe an IT application infrastructure in an Ansible playbook. So you can tell this is a marketing slide because it uses the word perfectly. I guess, I've never seen anything work perfectly, but I would say that Ansible does a pretty good job. It comes in two different components. Basically, Ansible core, and that is the playbooks themselves that I'll show you in just a second. But it is what does all of the work. It is what does all of the automation. It does the heavy lifting. It's what goes out and automates the things. And then you've got Ansible Tower. That is basically it's a framework for controlling and securing and managing your Ansible playbooks. Basically, you have all this power in code form. You need a way to be able to execute that in a way that gives you roles-based access and gives you logging and allows you to integrate it in a CI pipeline. In addition to that, however, it gives you an API to manage the whole thing, which I'll talk to you about in just one second. Why Ansible in particular? It's simple. If you go look at it, it's YAML, right? And I think probably most people have seen YAML, but it's yet another markup language. It's a really simple way of expressing content that's human readable. In fact, most of the ops people that I talk to, I don't defy them not to be able to get up and doing useful things in a day, but very often they can get up and do useful things in a day. Once you see the base structure and see how the modules work, it is really easy to do useful stuff. It's powerful in that it's modular and it has about 1,000 modules contributed from 100,000 people that do all different kind of things. From light bulbs to PDUs and servers and cloud and anything that you can think of, because it's really easy to do these modules, to create these modules, and just the popularity of Ansible means that many people are creating these modules. And maybe most importantly is agentless. By definition, it doesn't have to have an agent on the endpoint, which means that you don't have to depend on the manufacturer of that endpoint to have an agent for Ansible on that endpoint. All you need is to be able to SSH to it, or CLI, a Python binding, anything basically, right? So if there's a way that you can communicate with this thing remotely, Ansible can manage it. The way Ansible works is you have these playbooks that specify the end state. that you want to achieve with the infrastructure. And then you take these playbooks and you run it against an inventory. And this inventory can be out of a flat file. It can be your instance list out of AWS. It could be whatever database you have. If there's not already a script to go pull that data, it's relatively easy to go and build a script to go pull that data out of the database. It then takes this and leverages the modules through the API and plugins to then deliver this intended end state out to the hosts and the network and the things at the end, right? And also cloud infrastructure. A quick example. Now, this is most of an example. I cut off a little bit of the bits at the top that reference the list of hosts. But what you see here is a playbook that has 2 plays in it. And these plays do relatively simple things, right? This is a network thing, but they all work the same way, which is nice. It's basically the same way of automating the different things you want to automate. So you kind of learn once, and you just have to go understand sort of the module to go from one type of device to the other. But what you see here is two types of modules. One is what's more what I call kind of a primitive module. It's you have to have some knowledge about how this device works. And so in here, this is specifically for Cisco Nexus switch, and we use the specific incantation of host name and IP domain name to set the IP, the name of the device and the domain name of the device. Again, you have to know a little bit about it. And then I've got an example of what I call more of a declarative module, right? You don't have to know the specific directive on the switch. You just tell that module, hey, I want to set the NTP server. I don't care how you do it. I don't want to know anything other than just whether you've set this NTP server the way that I've asked you to set this NTP server. And we even have a simple construct here, a data construct here, NTP servers, which is essentially a list of, you guessed it, NTP servers. And so this bottom module, what it does is it iterates over that list of NTP servers, and for each one of those items, it simply replaces item with an IP address of the IP address of the NTP server, right? So simple data structure. There are actually, there are more complicated data structures. There's dictionaries, and you can even do some pretty powerful things, some pretty powerful data transformation with a templating language called Jinja 2. Again, it's not scary. It's not like learning Python. And so I'm hoping and assuming that most people in the room kind of see what this playbook's all about. It doesn't, you can get a lot more complicated, but you don't have to get a lot more complicated. So you can do a lot of interesting things at this level. So when we run this example, again, we're going to run it with just Ansible core, which is just this command line Ansible playbook. We're basically saying, okay, here's the playbook, and I've got a list of hosts. Seek this end state on this host. And so it runs this first play, and it says, hey, these 2 switches are already named the right thing. It's okay. I'm not going to do anything, right? Because if it's at the end state, I'm just not going to touch it. And then for the first NTP server, it does the same thing. It says, hey, this is already set. This is me personifying it. It never really talks back to you. But then it reaches this other NTP server, and it says, hey, this is not what it needs to be, so I'm going to go ahead and change it. I've changed 1 thing, 2 things are okay. And this is just an example of it seeking an end state. So pretty easy. When you go and define this infrastructure as code, you want to do so in a way in which you keep your data structures infrastructure agnostic, right? The idea of separating the definition of the implementation, so you only define your network once. And then that way, if you want to, well, 2 things. You can take that and you can apply it across several different infrastructures. So for example, you can define policy once, who gets to what, where, when, and how. Right? And then you can take that policy, that same policy, and push it into IP tables on a Linux host, and you can push it into a firewall, you can push it in IDS, you can push it up into access groups, up into the cloud and the host behind there, right? So you've got one enumeration of policy, but you've applied it in N different ways. And this gives you a power that you've not, well, I shouldn't speak for you that you've not had before, but lots of people have not had before, because there are all these different places to specify policy, but it's just too hard to do all of these different places. So you've settled for one sort of hard, candy coding and leave the soft nougaty core because you just don't want to push policy. But with this, being able to specify once, being able to define once, and apply many, you can have more of this defense in depth posture where you're secure, you apply policy at all levels. And this is just one example of the goodness of decoupling the definition from implementation, moving to different vendors, for example, right? You don't have to go re-architect everything. You simply change how you deliver that infrastructure agnostic or vendor agnostic schema down onto the infrastructure. And once you've done this, you can pipeline all the things, right? Your CI/CD pipeline is really the great abstraction from infrastructure. If you have all of your artifacts in your CI/CD pipeline artifact repository, then you can deploy those artifacts wherever you want to. From playbooks, right, that we've said can automate everything from PDUs to the application themselves, from the VM, from the instances and the containers, and even code for function as a service. You can deploy all of the things from your CI pipeline to wherever you want those things to live and have a happy life. And I mentioned that Tower also provides an API. This gives you really interesting capabilities. It essentially gives your infrastructure, your entire infrastructure, hardware, software, it doesn't matter. Ansible don't care. An API. So things like I often talk to customers about their log analytics systems like Elk or Splunk, right? So these things tend to be the smartest thing on your network because you're sending all of your information to it. But generally, all it does for you, it gives you good operational intelligence and will warn you when things happen, which is all great. But imagine being able to respond to the things that happen, right? Whether it's an intruder or a malicious actor or just disks running out and you have to provision more, you can actually reach out into the infrastructure through that API and actually address those things that your event correlation, your log analytics system comes up with. Or if you have a self-service user portal where you got add, moves, change, and you would normally have a human in the loop, you can actually have that reach out and exercise the API directly to automate what needs to be done. And so to give it kind of an example of how you might use this, I submit for your consideration Red Hat OpenShift. So there's an example of a platform. It's essentially Red Hat's enterprise-hardened Kubernetes and container orchestration platform. And in addition to kind of the standard, again, enterprise-hardened Kubernetes, we roll around often needed services, for example, or capabilities. For example, persistent storage or a registry that contains secure containers with a secure software supply chain. And then we also have underpinned it with a service layer. And these service layers can essentially offer services to the apps that you're creating in your orchestrated container platform, right? And all of this runs across physical, virtual, public, private. We don't really care where it is. It's a common platform that you can run everywhere to give you an enterprise Kubernetes capability. But what I really want to focus on is this service layer, and this is where the Open Service Broker API comes into play. It defines an HTTP interface between the services and the marketplace. Basically, the service brokers advertise service offerings into the marketplace, and then when a consumer orders that marketplace service, the broker then responds to firing that up. We support it in OpenShift, it's supported in Kubernetes and Cloud Foundry and other platforms, right? So it is truly an open service broker API for providing these types of services. And when you fuse that with Ansible, you get a very unique capability to put any service you want available in this platform. So for example, there's some examples over here, right? But for example, you can have hardware load balancers or hardware firewalls, stuff that would have normally been hard to instantiate. If you can wrap the Ansible around it, you can do it. So you can provide a capability, a list of services that you would have been hard or impossible to to provide before. Another way of extending the capability of your platform is to be able to fire up services in AWS, for example, granular service like RDS or EMR or Redshift, right? So you can actually pick the service you want from wherever your platform exists. The platform could be in AWS, the platform could be on-prem, but it gives you the ability for users, for developers, right, even taking the ops folks out of the loop for these types of daily interaction, for being able to reach out and provision specific services. So that's all great. You can reach out and you can provision RDS, for example, but RDS requires infrastructure around it, and this is where Ansible comes in again. So not only can you actually help with providing these bare metal services, but you can actually with Ansible reach out and provision the infrastructure. So in this case, the spinning up RDS requires Ansible requires you to already have a VPC, a routing table. You can even add, virtual private gateway, anything you need to connect that to the back end of your network. And so what we have here is an example, again, relatively declarative. You don't have to know all the bits of how this works, but all you do is you create a network, you create a subnet, and some other stuff that I couldn't fit on the slide. Now, this is all great and good. It's not, transformative, right? You could do this with CloudFormation, and CloudFormation is a great tool, but wait, there's more. With Ansible, however, not only can you do it for whatever cloud infrastructure you want, but again, you can do it in the infrastructure. So you can have Ansible not only provision the cloud infrastructure, but also provision the storage and boot the server and ensure that the VLANs are present. These are just really, simple examples of how these things are done. But basically means that you can provision the entire infrastructure, the underpinning of, in this case, OpenShift and whatever platform you want. It probably could be virtual metal, not virtual metal, I think that's not a thing. It could be bare metal, right? But you can provision all this stuff automatically, which gives you some really interesting capabilities. One, it allows you to automatically provision some of the infrastructure for the services that might spin up, or I mentioned bare metal firewalls or bare metal load balancers or something like that. But if you want to get really creative with and very complete with your DevOps testing, you can actually, when you want to test a new piece of code, you can fire up the entire infrastructure from, again, PDU all the way through the cloud and the application, giving you a sterile infrastructure to test your code. Or if you want to test new versions of the platform or new versions of whatever, you can include that into your automatic testing regime in your CI pipeline and fire up the whole thing from soup to nuts. So you put it all together, and you've got a very, very capable CI/CD pipeline that gives you everything, that gives you the ability to automate everything from the infrastructure up through the platform and application into the cloud. So if we put all this together, what we get is a truly DevOps-driven, services-based hybrid cloud. So I've been doing hybrid cloud for a very long time, and when you talk about moving monolithic applications, sloshing big applications, or even microservices type applications, whole lock, stock, and barrel from cloud to cloud or on-prem to off-prem, I don't really see that very much, right? But what is actually an interesting capability with hybrid is being able to instantiate what you want, where you want it, when you want it, right? So in this particular case, we have a private tier where we have some sort of back-end processing on a container orchestration platform near the data for some back-end processing. I think I already said that. And then from that platform, you can actually spin up things like Elastic MapReduce or Redshift or whatever in the clouds that can also communicate with a public tier. So say you want to present this data to your consumers, it makes sense that you probably would put that in a public cloud, right? And then even beyond that, you can go ahead and automatically provision the content distribution network, the DNS load balancing, and the Elastic load balance. That gives you truly a fine-grained hybrid cloud to put where you want it, when you want it, and then to integrate all of that into your CI/CD pipeline. So to be honest, I've only practiced up to this slide, so I'm going to end now. And I think we're going to maybe take some questions, if there are questions.
So first off, thank you everyone for coming in for the talk today. Please fill out your evaluations. They're very important to us. We like to get your feedback. Steven and I are going to stand over here, answer questions for the next 10 minutes, so feel free to come on up if you have any questions. Thank you, everyone.